Hey everybody, I assume the stream's online. So yesterday we had ended with a mock interview. Today is going to be kind of the same way, except for that the mock interview is going to be the next stream. So if you're watching this as a VOD, there's no mock interview in this VOD unless I end up streaming for like 9 hours, which I guess you'd be able to tell by now anyway, if you're watching the VOD. Hey Avery. So let's go combine some commands. Let's see. Here. So this. All right, so it's Thursday. More interview prep. Feel free to provide your own input while Adam's solving problems since he doesn't look at chat while attempting them. Read after it's done. For more information about why he's doing this, read this. Yeah, okay. I'll do the whole commands of interest thing, I guess. I hate Vivian. Mock interview. Mock interview plan for, yeah. So this, I'm going to need to change a little bit. And let's make an alias for mock interviews. There we go. This will take a little bit of time to get done with. So as a mock interview planned for 5 p.m. PDT today with Gio. Yeah. I was in the hospital all last week with a collapsed lung. Oh man. I'm sorry to hear that, Avery. Is everything better? And thank you for the resub. Thanks for the entertainment while I was in there. Oh man. I'm just picturing there's someone in a hospital bed. They're like propped up by the bed and they're like, oh boy, it's time for TV. They turn on a programmer and the hospital attendants are like, what's going on? They used to watch baseball here. Well, I'm glad to hear that you're doing well. And I'm glad to help pass the time. It's just such a funny thought. Obviously, you don't use a TV remote to control Twitch, but don't ruin my fun. All right, so as a mock interview planned for 5 p.m. PDT. Adam time today with CEO. That's it for the streamed interviews, but I might have more offline interviews. All I did was code and watch Twitch. Wow. Well, it sounds like you were productive. And it's good that you're better. So more interview prep. We have this. There is a mock interview today at 5 p.m. PDT, which means it'll be a separate stream since Adam will be ending this segment after maybe 2 to 3 hours. Yeah, I don't expect this to be too long of a stream. I don't even know how helpful it's going to be, but we'll find out. I have a plan for it at least. Now, there was maybe something else. Yeah, this is too much to fit in one command though, isn't it? Yeah, it's over by 77 characters. So I'll just write, Adam doesn't look at chat while attempting them, but he reads everything after the problem is done. Yep. Okay, now this fits. Am I still doing monologue streams? Yeah, this is a monologue stream. That's what I just got done making. This command took like 2 minutes to make. Hey Vettel and hey Thoros. Yeah, I don't think interactive streams are going to happen for the next probably couple weeks. Oh, also I should update this. Actually, I guess the system design ones kind of work, not the mock interviews. So it is July 30th. Goodness. One more day in July. Yeah. I had to apply to many places, realize what I wanted. Yep. At this point, I'm just waiting those to schedule on-site interviews. Yeah, I guess that's still kind of the case. I'm not really waiting for them so much as they're waiting for me to get back to them, so I gotta do that probably today. So I'll get there. I think this is pretty much it, though. Yeah. I think we can get started. Like I said, I have a plan. My plan for today is that we tackle medium and hard problems without knowing their tags ahead of time. And we kind of just see what we can do. Hey, Matas or Matus. And as always, and this goes for everybody, if I ever pronounce your name wrong, do let me know how your name should be pronounced. Okay, so let's change this to say type problem to see which problem to see what did I have written here before. Okay, this is probably gonna sound dumb, but I'm gonna go look at my VOD to figure out what it used to say when I was doing these. Type problem for the current problem. Okay, that's pretty good because it fit exactly, and that way I don't need to update the dimensions of this. That's why I wanted it to be the exact same. How confident am I regarding the upcoming interviews? What's tough about this, I was talking about that video that a Googler had done after leaving the company, and he said he did more than 250 interviews. And there's this kind of theory that there's a perfect team for any candidate and a perfect anti-team of interviewers. And I fully believe this. I think that no matter what candidate, you could have a total genius level person, you could have a total idiot, and there's going to be a team of people who hires them and a team of people who will never hire them. And I kind of look at this kind of like how I look at card games, where you could take the most skilled person in the world and there's some ordering of your deck that you could have such that you probably couldn't win that match. Now, how likely is it for those things to happen in both cases? Pretty unlikely. And that's why they try to have 5 people doing this and have an anonymous committee and whatever else that they try to do. So how confident am I? I feel like I've done as much prep as I really can. And now I'm going to start scheduling the interviews. And while I'm doing that, I'm still going to be prepping even more. So at this point, I've probably made like 80% of the progress that I could make. So if I were to spend another year doing this, there's only that last maybe 20% that I could even do. And how important is that going to be? I don't know. So we're going to try to cover another like 3% in the next week. But I can't imagine there's going to be anything too groundbreaking that I do in this time. So this is really just to solidify the concepts. Hey, Steve Vlad, how'd the stream go yesterday? And hey, everybody else. What an important greeting. Hi, one person and everybody else. Yeah. Prep coin concede. Well, I'm glad you enjoyed it. It sounded like there are a lot of Haskell appreciators out there. Interviews ended up being fizzbuzz. You know, if the interviews ended up being somehow very different from what I expect, I think I would be a little disappointed because these companies at this point have kind of advertised, hey, here's our process to me. And so if they were like, oh yeah, we just scrapped that whole thing, I'd be like, why did I prepare that? Hey, Play Rescue. So is it mostly to impress the interviewer, or is it a lot about finding a place you feel you really fit into? This is all kind of playing into this document. So for big companies, and some people are kind of surprised about this because I've gotten questions before like, is this how things are done in the US? And the answer is no, it's just the big companies. Or at least mostly no. I'm sure some companies do this. And so the interview process for these big companies is typically like 5 rounds of interviews. And it's also typically in person. Absolutely nobody is doing this right now. That's not a good idea. So, but they're usually in person, and they're usually some split of coding, system design, and behavioral. So all of the prep that I've been doing so far has been for these sections, and then this section I'll probably do just on my own on the weekend or something, because I don't know how helpful that's going to be for the stream. But yeah, so the coding questions, the system design, this document that I linked in, the title is something like "You Suck at the Coding Interview," and it talks about how most people, in order to prep, should take about 100 hours. So at this point, I think we're slightly past the 100-hour mark. I don't know how far, but if we're past it, it's like 105 or something. So not too far past it. And yeah, I'm starting to feel better. Like I said, it's about 80% of what I think is worth covering. So could I be doing things better? Yeah, for sure. Are things probably good enough? Hopefully. Am I applying to Fang? I'm applying to, it was Microsoft, Amazon, and Google. So I always thought it was kind of weird that Fang doesn't include Microsoft, although, I don't know, maybe it's a pay scale thing. I'm not sure. You wish for tree questions? I mean, I think what I want is for my prep to have not totally gone to waste. Because here's I said this yesterday, my biggest complaint about all of this is not that I'm learning about this stuff. It's that I could be learning about other things. So I'm learning X instead of Y is how I phrased it. And I still think there's value learning practically anything. So if they had said, "Hey, I want you to learn how to build a car," that's never going to come up on my job where I'm going to have to like assemble a car, become a mechanic or something. Or at least I'm not going to seek out jobs like that. And yet there's still some value in learning that. And who knows what links I would form to software engineering from that. This is a more closely related topic without still being very similar to what you're doing on the job. And what I'd rather learn are the kinds of topics that I had been doing the last few months. There were a lot of languages I was learning in the last bit of time. There was TypeScript, Golang, and Rust. And I never actually finished with Rust, and I never did projects in TypeScript or Golang. And I would have liked to do some of that stuff. Now, some people have kind of asked me before, like, well, wait a second, languages, why would you learn those specifically? And don't those transfer very poorly? And like, yeah, but I feel like they're probably more helpful to learn than algorithms and system design for now, at least to a point. I mean, I don't think it's worth doing 80 hours of algorithm questions, but that's kind of what happened. I think doing 10 hours or something is pretty reasonable. Hey, simple. There's no M because it wouldn't sound as cool as Fang. Yeah, I've heard they're kind of changing that term, or some people are, to like N star companies, or I don't know what. So have you mentioned before? Why have you settled on those? Is it technical, perks, prestige? What are you looking for? In general, I think my biggest goal right now is learning and having good engineers around to facilitate that learning. I also, one of the things that I really liked about Twitch has been the influence, and this goes both ways. So I don't ever say this stuff to toot my own horn. I think I have helped some people in chat either identify what they want out of their career or what good skills are to focus on or just any number of things. And then that same influence comes back to me where I learn a lot from chat and I also learn different things. I gain insights into my own development methodologies. And that's been amazing. And I wonder what that's like at a company because there's no way at a company for you to do that same setup where you're like, I'm going to stream to all the employees of this company and that'll just be my normal work day. I don't think that really exists. And I don't know how you would achieve that. I mean, I guess the closest you could kind of get is streaming on Twitch if you could somehow do your job and it's open source or something. But yeah, it's going to be a very different setup. So I kind of want to see how that applies to the corporate world again. And then, yeah, money is a factor. And part of the reason why money is a factor is because I'd still love to do Adam Learns again in my life at some point. And having the money to make it, to give it more momentum, I think would be great. Got hired at some point as an associated software engineer. Yeah. Yeah, I've heard of these sorts of things, and I think that this is an interesting idea. I think that if you have, let's say, like 5 years of experience and you want to get hired at a place, that getting hired is like you can't really try out many places if you have this setup. But I think being a junior engineer or being on sort of probation, some kind of temporary check to see if you'll be a good fit for the company, I think that's an interesting idea. It's great for learning because it makes you talk out everything. Yeah, I think it's not just that. I think to fully learn something, maybe I'm phrasing this wrong. Let me say this. In order to teach something, you typically need to have fully learned it. So this, I think, is true. I was going to say in order to fully learn something, you need to have taught it, but I don't think that's actually true. So I think this phrasing makes it a little bit more accurate. And a lot of times people will come in and ask me, hey, why are you doing things that way? And having to justify what you're doing, having to break it down to somebody who they just want a brief overview of what you're doing or why it's better than something else. The amount of times I've heard over the last 5 years, like, why do you use X? And the intent, I think, is to understand, like, he must have some reason for using it if he's using it. And maybe there's something I don't know. When sometimes it's as simple as, like, I've gotten this about, like, X could be Bing. Why do you use Bing? It's Bing rewards mostly. When it comes to technology, there's usually more than just, like, I'm getting money from this. So, yeah, I think that's really helped in solidifying the education. Am I going for senior? Yeah. And I'm glad to hear it, Maru and Avery. Yeah, and this is why I was saying I don't say this to toot my own horn. I know people in chat have said this to me before, and this is that influence I think is really positive and helpful. Did I study CS in college? Yeah, I used to, I think, have an FAQ about that, but I might have deleted it because I think people might have stopped asking. But yeah. if you say you want to be around smart people, that implies your current coworkers are not smart, or it implies you don't have coworkers. I mean, for the last 5 years, I had like 10 total people, and I'm not saying they weren't smart, but it's only one was an engineer, or only one was a developer. I think he was incredibly smart. That was Hideo, but that's just one person, and yeah. So I don't think it necessarily implies this. I think, at least not in my situation. Okay, so we're gonna get to some of these LeetCode problems. I think we'll just do a bunch of medium ones. I think that could be a good idea. And like I said, we won't look at the categories. So previously I'd been selecting by tags because the whole purpose was to figure out, am I good at this tag? But now we're just going to go through categories, or sorry, through difficulties, and they don't show you the tags here. So I won't know what that is. So I can't access any of the ones with a lock on them. I haven't paid for a subscription. So we just have to keep scrolling down until we find one that doesn't have a lock. This was a design problem, so we'd skipped that one. All paths from source to target. Okay, let's look at this. Was asked very basic questions given his experience. Is there a reason for this? The target position plays into what your spread of interviews will look like. So as you go more senior in Amazon, I think they care a lot more about the leadership principles. And yeah, let me fix the green screen. They care more about leadership principles and system design more so than just coding. Yeah, this shirt is never gonna be easy to key out. So yeah, I'll still be somewhat transparent. Okay, so yeah, I'm gonna go back to not reading chat now. And we're gonna do some of these problems. This is a little bit weird for a stream setup. I know it's not very interactive. So given a directed acyclic graph of n nodes, find all possible paths from node 0 to node n-1 and return them in any order. The graph is given as follows. The nodes are 0, 1, graph length -1, graph I is a list of all nodes j for which the edge exists. Okay, what are we doing here? Graph is given as follows. The nodes are 0, 1, graph length -1. Oh, I understand what's going on then. Okay, so this is the 0th node's edges. So 0 points to both 1 and 2. And then 1 points to 3 and 2 points to 3. So we form a directed acyclic graph that way. Okay. So let's edit the current problem. So first of all, just kind of parsing input. Each element in the array is its own array indicating edges from that node. And our goal is to find all possible paths from 0 to n-1. Okay, so any sort of exhaustive path listing is typically going to be best done as like a BFS, a DFS. It doesn't really matter what exactly. We could kind of think of it as dynamic programming. And we don't have to. And so I'd say step 1 is going to be form the graph. I don't think it's going to be possible to do this. Wait, actually, maybe, I wonder, would it be possible to do this without forming the graph? We might not explicitly have to, because I was going to say we can make a graph data structure here and then just call a function like list all paths from node 0 to x. But we might not need to do that actually, because we could, as we're iterating over the array, just kind of push, hey, this can go over to the next one. And we want to find the path to n-1. Yeah, so I don't actually think we need to do this. We don't need to do this since we can just iterate over the, well, since the array is a suitable representation of the graph. We access elements in constant time and never need to insert or delete. So we don't have any O of n operations on this anyway. So let's think of how this would kind of start. I think our algorithm would look something like starting at node 0, push unseen neighbors onto a queue, and then from that node, along with the path that led to it, and then keep doing this until we hit the end. If we do hit the end, then we add it to a list like our answer list. So let's look at the time complexity of this. We're going to start at one particular node, and we're going to potentially need to search every single node in the graph, except that there can't be cycles, so we'll never go backwards. So what could this be? I think the worst is O of n squared here, because we might end up with a graph that looks like this is node 1, and this points to 2, and this points to 3. This can also point to 3. There's no cycle here. And then if we have a 4, this can point to 4, this can point to 4. Whoops. And yeah, so for every node, we could have n minus 1 other nodes that it can point to. And so yeah, this has to be O of n squared. But I don't think there's a way to do better than that, because we're listing all possible paths, and all possible paths usually implies some polynomial time. So I think we would start this. So should I even write out the algorithm? I don't know if it's worthwhile any more than this. I think this is probably fine. Yeah, I think this is probably fine. So let's just get started, I guess. Now I am coding this stuff in an editor. Some companies don't actually have you doing that. But let's paste this in here. And then let's write out our tests that we have. So we take in a graph and we call all paths source target. And what we get back is an array of the paths themselves. And the issue with this is that they can be in any order. So we might get a slightly different one than what was expected out of this, but we'll deal with that, I guess. We just need to look at them and see if they're the same. Otherwise, you have to write a function to compare arrays in any order. Typically just sort and then compare. Okay, cool. So there's our thing. And what was our algorithm here? Okay, so we have an answer list, and we're going to return that answer. And we're going to say like toVisit is going to be a queue starting with graph 0. And graph 0 is going to be an array of elements that we have to visit. So actually, this is not a good idea. So we're going to, because I want it to just be a node in the path that it started with. So I guess we need to do it this way. For each graph, and this is going to be an edge in that. We're going to do toVisit.push, and we want the node, so edge, and then the path leading to that node, which is going to be 0. Yeah. So then we say while toVisit.length is greater than 0. So next node to visit equals toVisit.shift. And this is two things. This is a node and a path. And now what did I say we're going to do? Push unseen neighbors onto a queue along with the path that led to it. Okay, so now we figure out the edges equals graph node. Now, is there any way for this to be null? They didn't actually, I didn't look at the constraints. Number of nodes is in the range 2 to 15. And the graph is as follows. List where edge ij exists. So I can assume probably from the constraints of the problem that there is no way for this to be null. But if there were, then I just write a condition here and my mouse is going crazy, and we'd check it. So what we're going to do is this is going to be an array that's something like 1, 2. And we're going to say for each edge's edge, we're going to push the edge, and the path is going to be the path that led up to this so far. But then we have to add on that edge. And also this should have been an array. That's pretty important. So we'll just, for the sake of ease right now, clone the path that we had, and then on the clone path, push the edge that we're going to get. Yeah, and we'll pass that in. Okay, then what we check is if we're at the last node here. And I'll just do this anyway. If not, is nil edges. Because we'll run into an issue when we hit the final member of the array, right? Yeah, because it's empty. Well, no, it's empty. It's not that it's nothing. Well, I'll leave it there anyway. All right, what was I saying? So we need to know if the node is the final one. If node equals graph.length minus 1, then answer.push path. There, that should be it. All right, so let's try out our code. And we got our actual output of 0, 3, and 0, 3. So we're missing the middle nodes for some reason. And let's look at what should be happening here, because our input is this. And we'll just kind of step through the code and find out what I might have done wrong here. So we start and we go through everything in the 0th array that we have. So we're going to get node 1 and node 2. And the path is always, the path is always going to start at 0. And we notice that that part's working fine. So yeah, that works. Now we pop this off of toVisit and we get the node in the path. This is not the final node yet. So we go into, because it's going to be the number 1 and the final node should be 3. And so we get the edges of that, which is 3. And we push this to our cloned path. So now it'll be 0, 3. Oh yeah. Oh yeah. So it needs to go through, the current node that we had. So technically we should do this up here. Yeah. And then delete this. No, that still won't work. I think what we need to do, okay, so what I had done here is fine, I guess, except for this path needs to also include the edge that we had, because that's always going to be part of that answer. Yeah, okay, let's try that now. Yep, now it works. Okay, so that's the code. I would typically try this with other test cases. We're going to just try to kind of shotgun through all these questions. So yeah, that worked. So if there were, in a real interview, I'd talk about like, what other test cases should I write and everything else. Let me read chat. Thanks for having my background. I wonder if he started picking problems without knowing their tag in advance. What I was intentionally trying to do at first was figure out which categories I would need to work more on. And for that, I needed to know the category ahead of time. So I went through every single tag on LeetCode and did a couple problems at least. Haven't jumped on for a while. Just saw you're doing a mock interview. Are you looking for a full-time job? Yeah. I have the job hunt command that talks about that. Are you alone in chat? No, it's just not many people are chatting usually when I'm doing these things. Oh, well, thanks to Veil Turtles. Yeah, I'm probably not going to be streaming as much. But for the next probably at least a couple weeks, it'll be roughly normal. Yeah, interviews are going to start for me probably next week and then continue for a week or two. And when I say continue, I mean there's only a total of 3 interviews. They just happen to be 5 hours each. And so there's quite a lot of time. And then depending on how these job offers align, I mean, should I get a job offer? Depending on how they align, I might need to go and re-interview at one of the companies, because I've heard from friends that some of these companies say like, okay, well, you got to decide in the next week. And I'm probably just going to say, all right, well, I probably can't make a decision the next week. When I say each interview, I mean each block of interviews. The interviews themselves are typically an hour, and there's usually 5 of them. Do you have any tips on starting with stuff like, I don't know what this is, so I don't have any tips on it. What is it? United States of America Computing Olympiad. Is this like LeetCode as a club? Sounds like it's like LeetCode maybe. I'm not sure. Yeah, I don't know. Yeah, I think it's this. And any tips on getting started with stuff like that? I think it is I think it's pretty much like anything else. There's some amount of knowing some fundamentals, which in this case, it sounds like they care about time complexity. They probably care about algorithms and data structures. And then again, I don't know what else. I'm basing this off of what very little I just read off of Wikipedia. So fundamentals combined with practice, and probably combined with some like mock competition setup. I think this is pretty helpful too. That way you can know how you might perform and figure out where you might need to practice more. I know that may sound like a kind of cookie cutter answer, but I don't think there's too much more at a high level. And I think the low level is to find sites like LeetCode, HackerRank. Do I target jobs with JS? No, I haven't been considering language too much, except for that I want it to be relatively new technology. I feel like, yeah, I feel like I'd want to be on the cutting edge of things. Maybe stream a like code. The only thing about that is that you can't. It's not usually your choice to stream your company's code. It's usually their choice. If you're doing open source work, yeah, you could probably stream it. But yeah, I think the kinds of things I'd be doing would probably be closed source work. Excuse me. Yeah, I think Rust would be cool. I name it, yeah. Okie doke. Let's move on to another one. Actually, no, let's not move on just yet. Let's look at the solutions that they talked about for this. Ah, no, it's not going to open. There. Okay. So Java DFS solution. I'm guessing it's pretty similar to what I had done here. Yeah, except for they don't add both parts of the path yet until they do this here. But anyway, yeah, it's pretty much the same. Now the DFS is to use memoization. Each node will only be visited once, since the sub result from this node has already been recorded. Yeah, when I had mentioned earlier that this is kind of like a dynamic programming problem, I guess that caching is something I probably should have mentioned. Yeah, for sure. Because if you have a bunch of, like, let's say the 0th node points to 1, 2, and 3, and then the next node points to 2 and 3, and then the next node points to 3, and then the next node is nothing. You don't need to keep searching these 3 nodes that you're discovering. So that's probably something important here that we should write down. Where do I want to write this? Binary search, linked list, generating all sets. I don't really have any place for it. Yeah. Oh well. Should you not factor the shift into the time complexity or not relevant? So the shift in the time complexity, we could always kind of think of this as like, could we just have removed that if I wanted to? And so we made this a DFS instead. We could have used a stack to represent this, and then pushing and popping are both in constant time. So yes, technically shifting here is going to slide all array elements to the left, which is going to be an O-bound operation on the size of the list. And since the size of the list could be as large as n-1 elements in the original input, that could add some amount of time to this. But yeah, we could have worked around that. Same thing with me cloning the path. We don't necessarily have to do that. This is sometimes just me trying to save these issues that I would probably optimize out later. And remember, in an interview setting, you're going to be able to talk about all those things. In a LeetCode setting, all you can do is hit the submit button. And then if you're Twitch streaming, I guess you can talk about it. But yeah, this is mostly just getting the habit. Okay, so insert into a binary search tree. Did we do this one? I don't know. Okay, so let's take a look at this. Given the root node of a binary search tree and a value to be inserted into the tree, insert the value into the BST. Return the root node of the BST after the insertion. It's guaranteed that the new value does not exist in the original BST. Note there may exist multiple valid ways for the insertion. As long as the tree remains a BST after insertion, you can return any of them. So given the tree 42713 and the value to insert is 5, so we have to go to the right of 4 and then to the left of 7. So it would be like this, yep. But then this tree is, yeah, okay, I guess you could just balance it. This seems like it'd just be extra work. And we're guaranteed. No, wait, maybe it's not necessarily extra work. Let's think about that. So let's say you had a tree like, what's a counterexample for where we would have to actually change the root node? Now let's just draw something and maybe we can find it as we do it. So maybe this is a 3 and this is I can't think of what would do this. So we know that what we're adding is distinct. So we can't add 3, we can't add 4, and we can't add 6 by the problem definition. Yeah, it's guaranteed it doesn't already exist. So we could add numbers like 2, 5, and 7 to cover all our equivalence classes here. 2 would go here, 5 would go here, 7 would go here. And all of those can just get slotted in as leaf nodes. I'm trying to think, is there ever a case where you would need to change the root? And given the constraint of you always have unique numbers, I don't think it's possible. Yeah, I don't think it's possible. Because they give an example where the root changes, but you don't have to do that. You could have just put this here. Now, here's a question that's always interesting, which is, have I concluded the right thing about even the problem statement, or is there some counterexample I could think of? And I think the only way to know if you've concluded the right thing is to look at this more mathematically of what properties would make it so that I would have to rearrange this. And would having the same numbers even force that on us? I think only if you needed to keep this tree balanced. Because if you have the number 5 and you want to add 6 and you want to add 7, you can basically just turn this into a linked list. And they said, yeah, that's okay. And at no point do we have to change the root. But if that's the case, this sounds like a very simple question. So I don't know. Let's try it. I don't see why we'd ever have to change the root. But if we find out that we have to, then I guess we'll rewrite our algorithm. So what is our algorithm? Let's write that out. So we start at root. If the value to insert is greater than the root, then insert at the right child. If the value to insert is less than the root, or I guess like we should say current node, then insert at the left child. And then here we say if no right child existed, add it as the right child and return. And if no left child existed, add it as the left child and return. There's one thing that's a little strange about this, because it says here to return the root node of the BST after the insertion. And the only reason you'd ever have to return it after the insertion is if you were to change it. Because otherwise they have the same root that they passed in. It's a parameter. So this leads me to believe I have not thought of whatever counterexample there was for this. Because like I said, this code is very easy. And we know this is a medium problem, and this is kind of metagaming a bit. But well, yeah, I want to think about this a tiny bit more. Is there ever a case? Because what I was thinking here for equivalence classes is we have 2 numbers that are consecutive. We have 2 numbers that are not consecutive. And those are the equivalence classes. And we could consider less than and greater than. But I don't think there's ever a reason. All right, let's code this. Like I said, if we're wrong, we're wrong. And I'll have to think about it a little bit more. Okay, so what's my code? Here it is. So we're going to say insert into BST root val, and this will be like our implementation function, and then return root, because we know we're never changing the root, and we'll call it node and val here. So if the value to insert is greater than the current node, so if value is greater than the node's value, then if node.write, if that's null, then node.write equals new tree node val. Otherwise, insert into BST node.write val. Cool. Otherwise, it must be less than. It can never be equal to because we were told that there are always distinct values. So all these lefts turn to, or all the rights turn to lefts, and then that's our code. So that's it. I mean, let's run through it on an example, I suppose. So we have this example, which I'll draw it over here. So we have 4, 2, 1, 3, 7, and we want to add 5. So let's look through the code. We call insert on the root, so it is 4, and our value is 5. So we drop into this. 5 is greater than 4, and the right side, 7, is not null, so we're going to insert into node.right with a value. So now we're looking at this node. Now we say 5 is not greater than right. So now we just check, is this nil? It is, so we add a node here. Yeah, sounds fine. I think there's got to be more to this. I think my assumption originally must have been wrong about the about reordering the root. But this is actually, I messed up something else. Let's take a look at this. So we're adding, let's see what our tree is here. Oh wait, we don't have to. We learned about this. You click console and then you click tree visualizer and it shows you. Failed to parse. What? Failed to parse what? I literally copy pasted. Okay, no, there it goes. Okay, so we have this and we're trying to add 88. And so my code would see that it's greater than 61, it's greater than this, and then put it here. That's what I think my code would do. Let's look at the code. So we insert into the root. Val is greater than node.val, yes. So go into, no, and that's not null. So go into the right. So now we're comparing this as our node. And we say value is greater than that, yep. And there is no right, so we add it there. Yeah, is that not a valid answer? What are these trees that they have? So first of all, is that even what my code is doing? It looks like my code added 88 twice. Oh, I forgot to return here. Yeah, whoops. Where's my solution now? I don't even know how to. Oh, and then we need to check for if the node is null. If root equals null, return null. And then we get an empty root. Okay, so fine. I guess this is the one case I hadn't thought of where they give you an empty tree. There's just nothing. And they say, okay, add 5 into it. And that turns into your root. That's a little bit silly. So how do we even check that? What is passed in as our root in that case? Because there is no root, right? So I guess we're not necessarily returning null. I guess we're returning something based on whether there's a value. Return new tree node value. Yeah, that works. Okay. Yeah. Let me read chat. Where did I make the problem? Here it was. Pretty bad with problem solving. Where should I start from? I think where you should start from is fundamentals and then easy problems. And you might want to do that in either order. You could start with easy problems and then realize, wait, I don't really know these. So I'll tell you what my strategy was. My strategy took a very long time to do though, which was I went to LeetCode. I don't have any affiliation with LeetCode or anything. You can go to whatever site you want, doesn't matter. And here they happen to have this section of tags. And there are something like 40 of these. I went through every single one of these, except for I think like brain teaser and design. I went through pretty much every single one of these and just did a couple problems and tried to see which ones was I consistently having difficulties with. Then I went back and just did those problems. Now this process took maybe 80 hours, 70 hours, something like that. So that's why I say it took a lot of time, but I definitely learned a lot doing it. What is FANG? It's typically just some of the biggest tech companies. So it stands for Facebook, Apple, Amazon, Netflix, Google. There are technically two A's, I guess. I know the command doesn't have them. Yeah. Have I done deleting out of VBST? Yeah, I think there was another problem that had me doing that, or something similar enough where it was not too crazy. Yeah. And hey, Lily. Another interview with a half iron shirt. And Perry, this is not true. This is ironed. It just has little transparent holes through it because of the green screen. I'm just gonna wear a green screen tomorrow. Okay, calculate salaries, all elements in two binary search trees. We're just gonna keep going through this. Yeah, I know the camera doesn't like it. It's better on dark backgrounds, right? Yeah. Okay, so let's take a look at this one. Added this to the current problem. I forgot I made the backtick EP auto hotkey script so I can just press space and it types out the whole thing for me. I should use that. So given two binary search trees, root 1 and root 2, return a list containing all the integers from both trees sorted in ascending order. Okay, so here's like my gut just immediately says we do an in order traversal to get sorted lists, then march over each list and compare elements. And so we'd have, this would be O of n to get the sorted list, and then O of n again to iterate over the list. Yeah. Yeah, that sounds pretty reasonable to me. Because you, wait a second, what? Oh yeah. Okay. I was like, what are we looking at here? Is this not a binary search tree? But it is. It just looks a little strange seeing them both like this. Yeah, so this solution should work. Is there anything else I'd want to do? Can you do this as you're traversing? I guess you don't know that the trees are the same size. Although even if you did, I don't think that would help you. Yeah, so I think this is kind of just what I want to do here. Yeah, sounds good to me. Okay, let's go code that. LeetCode. All right, how much of this do I want to write out as? Yeah, there's only one answer for each of these things at least. So let's write out the whole thing. This will take a little bit of time. So we're going to write this as root 1, root 2, get all elements, compare if they're equal. Okay, so we got some tests here. 2, 1, 4. Oh, it doesn't work that way. Oh, man. I have to write code to first convert this into a tree if I want to have these test cases work. Let's just come up with a couple of examples then, because I got to write all these out. So example 1, root 1 equals new tree node 2. And then we set the left of that to 1 and the right of that to 4. And then we make another one of these. Root 2 is going to be 1, 0, 3. So now we pass in example 1, root 1, example 1, root 2, and then our output of 0, 1, 1, 2, 3, 4. I'm not going to write another one of these. So in order traversal to get the sorted list. So let's write out some of the pseudocode for this stuff. In order traversal is LNR. So that's our visit order. And so we could pretty much, let's think how this would look. In order on a node is going to be, we probably want like an accumulator array here. We could say something like, so if not is not, well, I'm writing this out as code. I guess we'll say in order node dot left accum. No, I'm still writing this out as code. Maybe there is no way to say this any easier than just visit the left and then the node itself than the right. All right, let's just write it out as code then. Function in order, node vacuum. So if the left exists, then in order node.left vacuum, then vacuum.push node.val, and then the same thing with the right. And there's one last thing, which is if the node is completely null, then just return nothing. Okay, cool. So we're going to say sorted order 1, sorted order 2, and then run in order on those things. All right, and let's just see if that part works. So we should end up with the sorted form of both of those trees. 1, 2, 4, 0, 1, 3. Yep, that's pretty good. Okay, so there's our in order part. Now the second part, we need to march over each list and compare the elements. So we now know that we have 2 sorted lists. Where are those? So hard to highlight. So we start like a pointer 1 and a pointer 2. The way I kind of like doing this is by drawing them. And so compare element at pointer 1, or what do we call this? Like sorted 1, pointer 1, to sorted 2, pointer 2. So if, let's just swap these things. It doesn't matter whether we swap them or not. What matters more is if we get, so this one's greater, and this one's greater. So I actually want a combination of them where this one is greater and then this one is less than. So something like that. Now 1 is greater than 0, 2 is less than 3, 5 is greater than 4. Let's also consider whether they're the same. Yeah. So compare sorted pointer 1 to sorted pointer 2. So if val1 is, I guess let's do this case. If val1 is greater than val2, then take val2, advance pointer 2. In all other cases, I guess we would take val1, advance pointer 1. And then we have a case where we got to the end of one of the arrays. So if val1 is greater than val2, or pointer 2 hit the end, I think I said that wrong. Val2, no, pointer 1 hit the end. And while pointer 1 and pointer 2 didn't both hit the end. Yeah, okay, I think that'll work. So let's consider this. So we have our final answer here. And we say neither one of these has hit the end yet. So now if pointer 1 hit the end, it did not, or val1 is greater than val2, it is, then take val2, so 0. And then advance pointer 2. So now we're here. So now neither one, or not both of them have hit the end. One hasn't hit the end. Val1 is not greater than val2. So now take val1, advance pointer 1. So now we have a 1. Now we do that again. Val1 is less than val2. So we take a 2. We advance this. We take the 3. We advance this. And now they're equal. So we're always going to take val1. Now there's a 4 here. And now the pointer 1 has hit the end, so we're always going to take val2. And now both have hit the end, so we break out of this loop. Yeah, so there's our thing. So let's go code that. So we'll say pointer 1 equals 0, pointer 2 equals 0, while pointer 1 is less than root1.length, or sorted order.length. Let's just say like max pointer value. So this is when it's hit the end. So when it hits 3 is when we've hit the end. Yeah. So this is technically the first invalid value, not the maximum value. So this is less than the pointer 1 value, and pointer 2 is less than max pointer 2 value. So if pointer 1 equals max pointer 1 value, and if there's nothing in the array, yeah, then, and then we need value 1 and value 2. Val 1 sorted 1 pointer 1, val 2 then take that as our answer. So our answer is like final sorted order. And we push val 2 onto here. Otherwise, we push val 1 on here. Here we advance pointer 2. Here we advance pointer 1. Here we return the answer. I'm just going to run this. Okay, so we got 0, 1, 1, 2, 3, and we missed the 4 somehow. And also nope, we didn't duplicate ones. Ones are supposed to be there like that. Okay, so my first gut feeling is to just check, did I mess up 1s and 2s somewhere? 1, 2, 2, 2, 1 equals max pointer 1. 1 is greater than about 2. No, I don't think so. So something got to the end of this where we did not end up adding a 4. So we got to the point where we hit the end of the second array. Yeah, maybe I did not write that down. Yeah. So pointer 1 wouldn't have hit the max value. And then this won't necessarily be true. We could default this to a very low number so that always ends up working out. They're between negative 10 to the 5th. Yeah, so we can just default this to negative 10 E6. There. That should do it for us, I think. Because I want val 1 is greater than val 2. Huh. No, I think I got my condition wrong here. I did. Pointer 1 has not hit the end, or val 1 is greater than val 2. Wait a second. The 4 is on the first array. So what we need to hit is this code. And this condition is not true. And then this condition I just made true. So I guess I meant to write 10E6 here. So that it's false no matter what. Yeah. And that still doesn't work. Okay, I'm going to debug this. I'm not sure what I'm doing wrong here. But I think it's just this last condition that we have. So let's enter the debugger. All right, we'll put this here. We know it's right at the very end of this that things are going wrong. So pointer 1 and pointer 2 start at, oops, I didn't mean to do that. Start at 0, and we get to the point where pointer 2 hits 3, which is the max number. So we're going to go to here. So pointer 1 goes up, pointer 2, pointer 1, pointer. Expression evaluated a falsy value. What? What's the length of these arrays? It should be 3. But it stopped when we got to 2. Yeah, I have an off by 1 issue somewhere. I wonder if I should just switch to using iterators for this. Because I think I have the right ideas for all of this. And I think I messed up something else, but what? So when it's equal to these. Yeah, I think I'll just step through a little bit more carefully because we know that it's breaking right after this. So value 1 is 4, value 2 is 3. So our final order gets 3 pushed to it, and then pointer 2 goes up to 3. Oh, whoops, I wrote my condition wrong. Yeah, I knew it. I meant to say, well, either one is less than. This always ends up happening with this. I phrase this as, well, both didn't hit the end, which is a very weird way to say that. Okay, let's see. Yeah, now it worked. All right, yeah. That was a little bit silly. All right, so let's submit that. Yeah, that worked. Okay, well, it's a little bit silly. Do I work at a FANG company? No, I've been working at my own startup for the last like 5 years. And yeah, I used to. Also, I hate Richie. I hate R-Cool. Biggest problem I have with programming is that sometimes I have a solution, but think like there must be a better way of doing it. I think this is an important feeling to have in your head. I think the only time it's bad is when it paralyzes you. So we kind of talked about this yesterday. Yesterday, I had a mock interview with Bremer 13, and I think one of the really good pieces of feedback he gave me is that I talk about ideal solutions and not, and when he said I, it's Adam talks about ideal solutions and not the real world solutions. And at least in an interview setting, I think this would be very different for me on a job somewhere because I would know that we don't have infinite developing time. But this all depends on what your interviewer wants to hear. I think it's good advice. And so, in an ideal world where let's say you had a year to focus on one component, and you want it to be as optimal as possible, what would you do? And you have to compare what that solution would look like compared to what you can actually do in the time that you probably have for something. And most often, you're not going to have a year to work on some trivial component. I can't imagine when you'd ever get some time like that, because if you had a year, that means it's not really trivial. So when you're coming up with an algorithm, if you have an O of n squared algorithm and you know that your input size is like 8, then that's totally fine. You probably don't want to spend any more time on this because who cares? You're going to get up to something like an order of 64 operations. Big deal. Doesn't matter. But let's say you have that same algorithm. Now your input size is like 1,000,000, right? Now all of a sudden, maybe it's worth coming up with a better solution for this. So it's always on a case by case basis. It's not like you see a time complexity and you're like, well, that can never be done. Because yeah, maybe the input size is small. Maybe there is no better algorithm. Maybe this is done so infrequently. Maybe this is just for the sake of analytics and it's your engineers you're holding up and not customers. There are any number of real world considerations that need to go into that. So I think having this is what makes you an engineer, and knowing when to act on that is what makes you a good engineer. Yeah, LeetCode still using var. Am I using a Vim plugin? No, I'm not. Nice, Nano. Spend those points. Are you allowed to use libraries like Lodash in interviews? The way I always say this is one key foremost thing is it depends on the interviewer. And two is if you're using functions that are trivially easy to write, then yeah, you can probably use it. So like the sum function goes through an array and sums it to whatever number the sum would be. Could you write this yourself? Yes, trivially in a for loop. You could use reduce. So functions like that, yeah, pretty simple. Same thing with like is nil. This is just comparing against null. Could you write something like sort by if you're tasked with writing quicksort? No, you can't. Because your interviewer's going to be like, okay, cool, you know how to use the library. Now can you tell me how you do it? How do you draw those the arrows? I used AutoHotkey. You type up arrow and down arrow. Yeah. So I have AutoHotkey on Windows. It's using what's called hot strings. So you might have seen me ever type something like, what was the thing I've been doing lately? Like this backtick EP for editcom problem. Or I have like a whole lunch command list thing that types itself out. Those are hot strings. And they're very helpful. And they're also helpful for typos. If you type te and you meant the, just press space and ignore it. Hey, Jim Jan. Why don't I work there anymore? So I worked at Microsoft for about 3.5 years. I have no problem with Microsoft. I didn't like the job. And that's for a bunch of reasons. I was an SDET, which is a role that doesn't really exist anymore. But as a software development engineer and test, I was working on Windows security. I didn't really like security too much, but I especially didn't like the test role. And yeah, it felt like a drag, so I left. And now the reason I'm going back is because I have a very different mentality about engineering since then. Back then, I think that challenges I encountered on the job, I expected someone on the job to help me with. And now I expect that I would have to work through them. And I think that was just the wrong way of looking at things back then. I think really mentality plays a very important role in any job you might have. And in general, having a can-do attitude is going to help you over being negative. And I think I was pretty negative. Copy paste the code directly in Chrome console. Copy paste what code? Because, oh, you're saying copy paste all this. Yeah, that's true. I could. Yeah, I usually run it through Node, and that way whatever I change in Node is going to be persisted to disk, as opposed to having to copy it out of Chrome at some point. Yeah, the while is definitely wrong. Yep, I had gotten that wrong. Yep. Yeah, pushing the remaining array is essentially what ends up happening here, but you're right, that when I find that one of the pointers hits the end, I can just start like popping all the values off of the other one. It's a good idea. Can you even know the answer before reading the question if they give you a time limit and max input size? Wait, what was this about? You can know the answer before reading the question if they give you a time limit and max input size for a problem. Huh. If you're going to use pointer like that, just use a Q next time. Oh, you mean just shift values out? I think that's what you mean, because like I had these in here and we're only ever like compare front values on both and then just take the lower one. The thing is, by using this as a queue, we end up doing an O of N deletion operation. Unless we sorted in reverse order, I guess. Which we could have done. Wait, could we have done? I don't know. Let me look at a binary tree. So we have something like this. To sort in the reverse order, we'd have to go. Oh, I wrote in order. Did I mean that? I think I did. Oh man, I'm messing up terms now. Binary search tree to sorted array. It's the in order, right? Pretty sure it is. Yeah, in order. So there's no way to get the opposite. Because there's no opposite of in order. No, I guess there is. It's pretty much just it's a traversal that doesn't have a name for it. Because I was thinking there's pre-order, there's in order, and then there's post order. But we could take in order and we could just have reversed it. Or maybe it has a name, actually, I don't know. But yeah, that would give us the opposite order. And then when we're popping elements off the queue, we could do it in constant time. Yeah. Why does VS Code look so different? Probably just the theme. But yeah, Brax, that's a very good point. How many years of experience do I have? Check out the ACJ command. Am I going back, meaning you had the offer? I meant going back to a big company, not necessarily going back to Microsoft. Also, I think I just scrolled like crazily far down. Are the scripts public? I mean, some of them are. They're, you can see it says Adam's scripts are available here. They're really not all of them, but then again, I don't really think you'd want all of them. I just made a change to something yesterday on here, and I don't mind uploading them again if somebody sees something that they like. Where did I make this? Some silly thing. Oh yeah, this. Oh, I've been watching a lot of YouTube videos for lectures lately, and there's a command I wrote called YouTube Speed, which types out this document.get elements by tag name, video playback rate equals 2.5. So by default, if you press the greater than sign on YouTube, it'll increase the playback speed, but it only goes up to 2x. And sometimes people talk really slowly to the point where 2x still feels like, come on, keep going faster. So yeah, sometimes it's 2.5 or 3. And then almost everybody who talks slowly has some sentence they'll say where they talk at a normal rate. And then you can't understand them at all because 3x speed is just like a barrage of words. Yeah. Yeah, if we're talking about speed running, yes, typing TEH is very important. What language did I use on Windows? It was all of the C family, except for Objective-C. So C, C++, C Sharp, and PowerShell, I guess. Could you move to a different position? I think I tried, and I think the only thing I wanted to move to at that point was gaming, and I met with someone who was a lead on the Xbox team, and I talked to somebody else somewhere, and they said, look, we don't have any positions open. And I thought, well, when will you? And they said, I don't know, maybe a year. I thought, I'm not waiting a year. Security, like pen testing internally. So that's what some people did on the job. And very briefly, I brushed up against some of those people. But in general, so SDE is software development engineer. The T stands for test. So you're basically a dev, but who writes tests. And at that point, I mean, well, you could kind of look at it as pen testing. It's not. How do I describe the difference here? You are still trying to find flaws in the product, but yeah, I guess it sort of is like pen testing. Some of it, at least. You're not necessarily doing the proof of concept that I associate with real pen testing, where you're like, okay, we have identified an exploit. Now let's prove that this can be done. Some people did do that, though, and that's what I was saying. I brushed up with some pen testers there. This is VS Code, yeah. Figure out what complexity they expect of your algorithm based on input bounds. Oh, yeah, that is definitely true. Yes. If they say, hey, we're going to have millions of elements, you can probably assume it's not going to be some n squared operation. Yeah. So these are things that I think I've got to internalize still. And I don't know where I write them, but I'll just write like file learnings from today. So if I'm iterating over two sorted lists and I'm just trying to merge them, the easiest way to think about it is to pop elements off the front of each array, compare them, put them in the right order, or pop an element off the lower array. Repeatedly until one array is empty. At that point, take all of the remaining elements from the other array. Yeah. Okay. Yeah, do it. Yep. Yeah, that's right. Volatile. And if for some reason you get a time limit for solving a problem during an interview, you can know based on the max input size. Yeah. Yeah. And thank you for clarifying too. It's QA automation. I mean, not quite. Like you as a tester would be involved with producing specs from when the developer was writing them. So you'd be able to point out like, oh, hey, have you thought about how it's going to integrate with this system? And then you would write tests based on being able to see the code. And yeah. So I don't know if you call that QA automation. If so, then yes, I guess. Did I work on Vista? No, it was Windows 8 and 8.1. Yeah, really. What would you expect someone to know if they're applying for their first senior position? I don't really answer this question right now. So, like, I'm applying for a senior position, and I could only tell you what other companies have told me. But what I think people should know is not necessarily what these companies have told me. So, what the companies have told me is generally coding questions, system design, and then, I mean, I guess some behavioral stuff. But that's not necessarily something you know. That's just something you kind of prep for. So yeah, this is what companies mostly say that I've been applying to. Is that what everybody says? No, not necessarily. Some of them actually do want you to be like an expert in some particular technology. Like, hey, we're looking for someone who has AWS experience. We want that. We want you when you join the team to have that expertise already. So all jobs are different. I think it depends on the company for sure. Didn't want those frames anyway. Oh my God. Yeah, I dropped a ton of frames. Sorry, guys. These frames are slippery. There. Have you seen today's daily challenge? No, I haven't. I'm just going through the problems from just top to bottom and just seeing which ones we can do. Okay, so we just did that one, I think. All elements in two binary search trees. Yeah. So next up is... All right, let's skip some of the tree problems. We've done a couple of those now. So if it says tree in the title, we'll skip it for now. Binary tree pruning, delete leaves with a given value. Again, that's a tree problem. Lots of these are tree problems. Wow, we've done a lot of the medium problems. The kth lexicographical string of all happy strings with length n. I think we looked at this one already. Whenever you hear the kth value, you can always kind of think of quick select. I think I looked at this. Well, let's see. Do I have a file on my machine for this? What's it called? The kth value. No, I don't. I don't know if this is worth doing though. Let's try it. It's not a tree problem, at least. You think you'll stop learning at your job at a big company? I think it could happen, but I think you generally at a big company have lots of opportunities to address that. You know the tree add algorithm like Heapify? What you need to know is kind of how to come to the conclusion for any of these problems that you might have and what you're reasonably expected. So do you need to know a specific thing? Not necessarily, but you should have some idea of how you'd figure it out. All right, let's look at this. So a happy string is a string that consists only of letters of the set ABC. Okay, great. And S of I is not equal to S of I plus 1 for all values. Yeah, so there are no two consecutive characters, I guess. So for example, ABC, AC, B, and this are all happy strings, and the ones with two consecutive characters of the same ones are not. Given two integers, consider a list of all happy strings of length n sorted in lexicographical order. Return the kth string of this list, or return an empty string if there are fewer than k happy strings. Okay, so we have n, which is the string length. We have k, which is the index into the lexicographically sorted array of happy strings of length n. Yeah, and our output is going to be, wait, output is C. What? Oh yeah, that string. Yeah, that string at index A. Yeah, so we came across a problem similar to this, and this is why I think this is good to review, because I don't remember anything about what I did then. So we definitely need to be pretty smart about this. So n can go up to 10, k can go up to 100. So knowing that k can go to 100 means that we could just generate k strings if we can generate them in sorted order. But knowing that n can go to 10, and we have 3 characters, so is it 3 to the 10th, I guess? I'm not actually sure, but there'd be 59,000 combinations. So this doesn't preclude searching through everything. So I guess one of the questions I'd have before I come up with an algorithm here is, how do we generate happy strings in lexicographic order? So the first strings are always ABC, right? Then AB, AC, BC. And then it starts getting a little bit harder. ABA, ABC, ACA, ACB. I'm only going to run out all the ones with length 3, and then we're going to be done with this. BAB, BAC, BCA, BCB, and we're almost done. There, I think that's all of them. Up to length 3. So we had 3, then we had 3, then we had whatever this is, 10 or something. So yeah, how we generate these. This is what I was, I think, trying to figure out the other time, which is, given any happy string, how do we go to the next happy string? And I think that's what we need to figure out here in order to generate this. Alternatively, another way I like kind of thinking about this is there some mathematical progression where we could see this playing out if we listed these all as, if we considered these to be just ternary numbers, like a equals 1 or a equals yeah, I guess A equals 1, B equals 2, and C equals 3. That might be a little bit harder to figure out. But in trying to compute this last time, I think I ran into some issues. So let's consider how to generate these. An empty string goes to A. And then A tries to go to B. But if that results in two B's touching. So for example, we had BA to BB. Then we go to BC. And I think this is the trap that I fell into last time as well, which is that there was some rule that I never completely worked out. And so this ended up being quite challenging. Because I came up with something here and then, yeah, everything got very tricky. So BA should go to BC. We could write out, I mean, pretty much a bunch of these. All of these go to the next one that we had in the list. So we can kind of just shift the list a little bit. So if we do this, that didn't work because we need one more cursor. There, that worked. Yeah. So here's our list of what goes to what. So we should see BA going to BC. Oh, I didn't even finish writing these out, did I? Whoops. Yeah, whoops. Forgot about BA here. And I forgot about CA and CB. I knew something was wrong. I'm like, this progression doesn't make any sense. Yeah, whoops. Forgot a whole bunch. All right, let's try that again. There. Okay, so we should see this in here. Yes, good. So I want to come up with a set of rules for this. Although actually, maybe this is the entire set of rules. Is there something else that needs to be considered here? What happens if we have CBA going to CBC? That always works, I guess. Although I guess we need to consider the final thing of CBC goes to something else, which is what, A, B, A, B. If we just coded all of these into a hash map, and then at any given point looked at these chunks of the string, would this let us generate the next one? Yeah. Use them to generate the next string. Would that produce collisions? So just want to turn on a fan. So happy strings, I don't think are common enough for me to remember what this sort of technique is. And in a way, I'm kind of approaching this from, is there a way to just get to the best algorithm at first? But something I just completely skipped over is we could always have just kind of brute force this. We just generate every single possible thing that's lexicographically sorted, filter out all of the non-happy strings, excuse me, and then we just pick the kth one of those. And that's not even unreasonable because we know there's 59,000 combinations. I just want to get to what I think is a better solution here, that we could generate this in exactly k operations, where each operation, I don't know what the time complexity would be because I don't know if this solution even works, but I still want to explore this some more. So yeah, so what do we have here? Let's say we had CBA goes to C. So we need something like CBCB. So this would try to go to CCAB, and then we'd have a collision here when we need to resolve it. And I think cascading these collisions until we've fixed them is probably the way to do it, and not this idea of a hash map, because we'd run into a problem here and we'd have to change this. And what does this even change to? CBCB. If we just look at that hash map, we'd take BCB and turn CB, but then we have CCAB, which is a collision. Like I said, I'm pretty sure this is the exact same train of thought I had the last time. And also, this would only mean that I didn't learn anything from the last time that I did this. But I have a feeling that what I'm trying to do here is not possible, and I'm still kind of working it out again. So how do we fix this? I think it's better to just fix collisions when they happen and follow these rules that I'm following as a person doing them. So in this case, what I do, how I work through it is increment the last character. So we turn the A to a B. Yeah. Then check for collision. If there is one, then we need to resolve it. So how do we get to that? So the first collision we have is, I guess, C is supposed to go to like AA. I guess C always goes to AB. Can we resolve these from the left side, maybe? What does BC turn into? CA. No, we can't do that. So EGC goes to AA. So if there is a collision, then yeah, how do we fix this? Then increment. And I want to come up with a rule that works for all of this. So BAC would go to BBA. But it should be BAC to BCA. Then increment the last colliding letter. Yeah, that works. That works in both of these cases. But does that work in every case? So we have BAB to BAC, then BAC goes to BBA. So we increment the last colliding letter to BCA. Okay, great. Next goes to BCB. Good. Then BCB goes to BCC. So BCB to BCC. We increment the last colliding letter. So we get BCAA. Branch chain amino acids. And then we go to, I guess, BCAB, which is definitely not correct. Because we're supposed to go to CAB. Yeah, okay. I don't know. I think this is the same problem I ran into at first, and I don't really want to code the brute force solution. So I think we need to learn how to generate happy strings. Man, I want to pursue this for a little bit longer to try to figure out, because I'm going to run into this again, and what kind of bugs me is I know I'm thinking the exact same way that I thought originally. Like, this is how I approach problems. And so I need something different about my approach to recognize not only that this didn't work last time, but what I would have done, I suppose. And maybe what I came down to the conclusion of last time as well is that, oh yeah, this is just a brute force solution and I don't want to do that. But I don't think that's true. I think there is a better way to generate the next string from what we already had. And even here, I could try to come up with a more complex rule for how we're supposed to handle this. Like if we have CC specifically, that's when it carries over. The last colliding letter, unless it's a C, in which case we increment the letter before it. So we end up with CCC, and then what do we do? Just try an AB. CAB. What else could we have? ACC. That's it. There are only two cases, so I guess it's not that bad, right? It turns into BAB, which is just incrementing the letter before it. Yeah, I think that's probably the way to do this. I kind of want to code this just to see if I can even do this part. So what I boiled this down to is given a happy string, get the next happy string. And if we just do that k times from an empty string, then we're done. So I want to try this. Yeah, we're going to write this. I want to see if this even works. Before I write it, though, we need to finish testing. So this is the real problem here. But we're going to write a function called get next happy string. And the next happy string is going to be... Oh, wait a sec. We always need to consider strings of a certain length. I also completely ignored that at some point. Although this isn't drastically different as a result. Because we can just generate strings until we've hit a length higher than what we want, and then we'll know we had every string. Target length. No, actually, we should just write get next happy string. Yeah, I don't even care about this. Last happy string. So assuming we had this, our final algorithm would be call get next happy string starting with an empty string until we've found enough target elements or found enough elements of length n, or we've exceeded n. Or no, not even that. Or we've found... Oh, no, that was actually correct, yeah. I already wrote this here. Until we found... I shouldn't say enough. K elements of length n, or we exceeded n. And that's it. That's our whole algorithm, I guess. So let's test this and make sure this works with everything. Because here's my idea. We increment the last character, check for collisions. If there's a collision, increment the last colliding character unless it's a C, in which case we increment the letter before it. So we increment this, no collisions, no collisions. Now here's where we have our first collision, right? So we go C, turns into AA, I guess. And then there's a collision, so we increment the last character to AB. This process on its own, the collisions can only ever be next to the character I just incremented. So we should be able to do this in linear time, I think. But I'm not positive. All right, so C goes to AB then. Cool. So AA to AB. Then AB goes to AC. Sure. Then we end up with, so AC is supposed to go to AA. No, I don't think that works. Yeah. I don't have a solution for that. And so I'm debating, like, again, I could hard code this hash map so that we kind of just know what they are for certain lengths. But then this kind of just makes me think that this rule won't work. Yeah, I don't know. I think it's best to just look at the solution at this point because I don't want to do the brute force algorithm. It says generate all the happy strings of length n, sort them in order. Yeah. I think this must have been exactly what I saw the first time I did this. DFS and math, yeah. Man. Build all possible strings. Yeah. There's no way to go from one to the next one? Maybe this one? No, everyone always generates all the possible strings. I wanted to see if there was a better way. Bit reading or event solution. Let me start with the last level. Yeah. All right. Well, yeah. I think I've come across this problem twice. I did the same approach twice. I probably came to the same conclusions twice. And I guess I really learned nothing in the end. Unless the conclusion I came to is don't be afraid to write a brute force solution at some point. I just feel like every problem on LeetCode, if the solution is brute force, it wouldn't be a medium problem. All right, let me scroll up. Have you done many DP problems? Yeah, I struggled with those too. I took a bunch of notes on dynamic programming as a result. I spent several hours over the weekend taking tons of notes, and I boiled them down to pretty much this. Here's my summary of pretty much everything. There are 5 steps, and if you follow those, I guess it's not too bad. But I think these steps aren't going to make a ton of sense until you read through some of the other things that are here. Yeah. But these videos at the top of the note are really, really good. I highly suggest watching them. Yeah, I messed this up. I definitely messed this up. Yeah, I think the way to do this has to involve generating them all. I just didn't want to look at that, I guess. Calculate how many values have duplicate digits between a range. Your answer is the value in base 3 plus the number plus the duplicate numbers count. Wait, this would give you a number in the end, but what you're supposed to get is the specific. Sorry, this would give you a difference. Anyway, I see what you're saying. I think you've still I'm not gonna be able to articulate this, so I'll just stop. Yeah, you maniac. No more system design. No more system design for probably no more system design for a bit. Also, I just want to point this out to a couple people in chat for right now, but please don't segment messages. Okay, so that one is, I guess I ran into the same problem as before. Oh man, brute force is okay sometimes. I feel like brute force is okay on LeetCode sometimes. I feel like it's not really ever probably going to be okay in an interview. Like, when would they want you to just do the bad solution? Or the naive solution, I should say. No, it's okay. It's not a huge deal. It's just, yeah, if you can type a message as one message, please try to do that. The character limit on Twitch is 500, so it's pretty permissive. It's like double a tweet. Okay, let's keep going. I don't think it's important to code that solution. I think it's important to realize how to get to the solutions. All right, we should probably just look at some interesting ones and not just keep going down the list. Let's look at bulb switcher. What is this? There's a room with n bulbs. Initially, all bulbs are turned off. Okay, let's look at this one. And RB, I will take a look at what you are saying when I get done with this problem. I agree, giving a brute force solution is better than nothing, for sure. And I think in interviews, they'd probably want you to say, here's what it would look like, but I want to keep looking for a better answer. So, yeah. All right, let me look at this one. So there's a room with n bulbs numbered 0 to n minus 1, arranged in a row from left to right. Initially, all are off. Your task is to obtain the configuration represented by target, where target I is 1 if the ith bulb is turned on, and 0 if it's turned off. So obtain the configuration represented by target, where target I is 1. 0 is off. Okay. I think I understand. So they're gonna give me a list of bulbs, like these are all off and this one is on, and then they're gonna give me a list of like a target, like I want you to make it so that this second one is on, and you need to figure out how to get there according to whatever rules they're about to tell me. You have a switch to flip the state of the bulb. A flip operation is defined as follows: choose any bulb, and then flip each bulb. So everything leading up to that. No, everything after that. So you can flip any number of bulbs from the end of the array. That's what it sounds like. Well, toggle. Turn the minimum number of flips. Okay, turn the minimum number of flips. This right here makes it sound like it's dynamic programming. We're trying to minimize something that we have, so we'll probably approach it in that way. Target is 1, 0, 1, 1, 1. Output is 3. So initial configuration, oh, they always start as off? Initially all are turned off, yeah. So never mind, our initial thing always needs to be a bunch of zeros. We always have all bulbs start in the off position. So we flip from the third bulb, so the last 3 are on. We flip from the first bulb, so all of them are toggled. Then we flip from the second bulb. Okay, yeah. So I think what we do is we approach this just straight up from the dynamic programming approach. And so the approach is something that I haven't looked at since like a week ago. So I'll have to think about this again. So we say to define our subproblems, figure out our guesses that we have here, then find the recurrence. Then what do we do? I don't remember step 4. And then step 5 is make sure we solved our original problem. So now let's look at this. So define subproblems, guess, relate subproblems, build the algorithm. Okay, sure, fine. I probably would have realized. I don't know what step 4 is, but we're going to need code at some point. Okay, so what are our subproblems here? So we are always looking to pick. I guess we're looking to see if we have. We can toggle anything from the end of the array. Still don't know what our subproblems are exactly. Well, okay, let's figure out the guesses. I guess our guess is going to be, do we toggle everything starting at bulb I? But we need to do this in a certain order, right? And here we went third, first, second. So we know there's no like just progress from left to right or just progress from right to left. But I'm pretty sure we wouldn't need to toggle any of these more than once. Want to start at all positions of I. And yeah, all of the others afterward. But this still doesn't really kind of work the way I wanted it to, right? Like the way I sort of think about this is we generate every like we need order matters here. Yeah. Actually, order does matter, right? Let me just think about this. We had third, first, and second. So third put us at 1, 1, 1. So let's say we did the first one. We'd be at 1, 1, 1, 1, 1. Then we do the second one next. So we'd be at 0, 0, 0, 0. And then we do the third one next. No, the order doesn't matter. Oh, so we can always start from the left. Yeah. Oh, okay. We can just iterate over the list for this. So our subproblems, it's basically we're trying to like the dp of I is going to be equal to, man, this is where I guess I didn't spend enough time drilling this into my head because I can like picture these videos again and picture how he wrote out what we're trying to minimize here. So minimize It's going to be, well, I guess we haven't done this in order. I still haven't said how our subproblems correlate to each other. So when we toggle the first one, we count that as like one toggle plus all of the other toggles that follow to get to our target. So it's a substring problem, I guess, is how I normally say this. And do we toggle everything starting at ball by? Can we just use iterate over the list for this? I'm not doing this the formal process anymore. I wonder if I should watch these 4 hours of videos again. Man, this is actually why my notes should come in handy, but I want to try not looking at my notes right now too. Yeah. Okay, so yeah, what are we minimizing here? Trying to think of, do we toggle the current bit? So it's going to be 1 plus dp of like I plus 1. But this also is going to need our current bit state. And like toggled light state. So the minimum of that, or just dp of I plus 1 with our sane light state. I think this is what we're going to consider here. Yeah, I think this is it. Okay, so we can try to think of how we reuse some of the state that we'd have, but I don't know if we'll ever run into the same configuration more than once. But that's because I'm thinking about it from left to right, not right to left. I'm trying to figure out what would I memoize here. To be honest, I think I have enough to be able to write the code, but I'm still trying to think about this from the formal dynamic programming approach. And I think I'm not doing a very good job at it. So yeah, what would I memoize here? Is there any, I don't think there's any like major amount of work we cut out here. Because I don't think we're ever doing the same toggle more than once. Because if we toggle bit 1 and like bits 1 and 3, we're never going to toggle those specific 2 bits again. Because we're only ever advancing in this list. So maybe memoization doesn't really matter too much here. Maybe we just don't for this. So how would we write out our code that we have here? Well, for one, this only matters if we get to our target. Yeah. I don't know. I got to review my notes on this. That's another thing I'm going to say. View my notes on DP. I've forgotten everything. Yeah, well, look at the solution at the end of this problem, too. Yeah, I might as well just look at my notes now. Yeah. So find subproblems, guess some part of the problem, relate the subproblem solutions to each other. Yeah, I didn't even talk about time complexity either. Number of subproblems times time per subproblem, yeah. Oh, what a shame. What a shame. Hmm. I think what I need to do is write down notes as I'm going through real world problems here. And that way I have the flow listed out. Yeah. Yeah. I definitely need better notes on this. Make notes where I've gone through real world DP problems to truly internalize a process. Man, what a shame. What a shame. Yeah, I feel like I stopped working on LeetCode problems for what, like 1 week. I think it's in 1 week exactly. And I just forgot everything. Well, what this means is that if I refresh my memory on this, then I'm probably going to forget all the system design stuff that I did. So I should probably study for longer. I wonder if I just shouldn't even schedule the interviews for some time. Anyway, I'm getting very like meta information about this. We should just focus on the algorithm for this. I actually don't want to do that. I want my notes to be better. Yeah. Okay. Let's try to write this out as an algorithm, I guess. So we're gonna have some function. It's called like dp light, and we take in a light number to toggle, I guess. Index, and it's going to start at 0. Then we take in our current light state, which is going to start at a bunch of zeros as well. And then we return the minimum of what we get out of this. Kind of want to do this. I guess we need to think of, do we start with the base case here? Or do we start with the top-down approach? Yeah, this is where I'm just not thinking anymore. Top-down versus bottom-up. So top-down would be to figure out a case with 1, 1, 1, 1, 1. Use the solution from case of length 5. Use the solution from length 4. And the bottom-up approach would be start with base cases. So length 1 to length 2. Yeah, this is where this part should be written out better. I think it would let me see this more clearly. But I just don't remember how to write this. And I kind of have it in my notes for some of this stuff. And we want the time complexity for all this at the end too. Yeah. I'm not really thinking of anything. I'm trying to fit this to the form that I used. Man, I'm like ultra dejected now. And it's making me so I'm not even trying to solve the problem in a different way. I want to solve it in this way. And I know this is like the classical way of thinking about this. And of yeah. Yeah, I'm not gonna get this. I think I need to look through my notes again. Yeah. That's too bad. I'll definitely I'll write this down for the future, I think. So I'll spend some time doing this for sure. So disappointing. Just so disappointing. Yeah. I forgot step number 4, but I also don't remember the parts of each step that are important. And I didn't write myself going through any of these. Because I remember I tested this the day after I watched all of these, and everything went very smoothly. And then, yeah, I think I just forgot it all. Yeah. Yeah, too bad. Okay, well, I'll rechat. Yeah, string questions. I'm going to try to be ready for pretty much everything. And I agree with this, Jesta. Yeah. An interviewer needs to at least be able to see something to know that you can think through a problem and at least come up with any answer. Yeah. What videos am I referring to? They're in the notes. They're the MIT lectures at the top. Yeah. No, I don't mean reschedule the mock interviews. If the mock interviews go poorly, I think all it means is that I need more practice. And this is almost like a mock interview. But no, I think for today we should be fine. Oh yeah, this is actually another way of thinking about things, which I didn't even stop to consider here. The way when I was first doing dynamic programming problems on stream, I said, I'm going to follow this very rigorously so I can internalize this because there were problems that I wanted to solve using dynamic programming, and I hadn't encountered this when I went through school. So that's whenever this was. I don't know, July 18th, I guess. Yeah. Okay, so 12 days ago is when I finally did all this searching. That was, I think, a Saturday, right? Friday. Okay. Yeah, I took a bunch of notes and I was like, okay, let's fit this to a bunch of problems. And I'm very stuck on this concept of the I don't know this. So I gotta work through that. Yeah. Yeah, I can't get this idea out of my head that like that was at least 6 hours of training that I've just ejected from my head. And I agree, this is overthinking. Yeah, I totally agree. We could consider this to be a distance between two bit masks. But I'm so fixated on this idea. Gotta get it out of my mind. You just count the bits transition starting at the most significant bits. Yeah. Do you have issues with dynamic programming in general? Like I said, until about 12 days ago, I don't think I ever formally knew dynamic programming. And I always equated it with, oh, it's just recursive problems. And it kind of is. It's recursion plus memoization, essentially. Yeah. Yeah, Smurf, I agree with this. I think, like I said, it's very different if this were, 8 years ago that I spent, I don't know, an hour on this or something. But we're talking about 12 days ago that I spent probably, I think, 6 hours because the videos themselves were maybe 4 hours. There were a ton of notes I took. Actually, we could just see what times I took these at. This is at 2:27. This is at 3:01. This is at 2:30 somehow. Okay, I probably bounced around in my notes. Then this is at 10:30 p.m. Okay, yeah, apparently these are all over the place. So never mind. I remember now that I watched them over multiple days. That's what happened. But yeah, so this is very recent that I've forgotten practically everything about it, and that's really bad. And I think that definitely clouded my judgment on this issue too. Currently in high school, I want to work within IT, but here where I live, you can either get an engineering degree or computer engineering or bachelor's. I think this depends on where you live in the world because I think even in the US, there are certain states where engineer has a legal connotation in addition to just the regular connotation. And I don't know if you need that for where you live or where you want to work. So that could be a consideration to make. But other than that, no, it's not important. I have to give you the spiel of my mental model for after or later today. Yeah, I I definitely need to. Yeah, I think that would be helpful. I definitely need to brush up on this. Are they updated in real time? They should be. Yeah. Yeah. Can I recommend a resource on graph? I understand the theory, but implementing with code is a big problem for me. Typically, I just start with Wikipedia because there are usually, like, if you look up breadth first search, there are going to be some good resources there where you can just look at pseudocode and this will hopefully make sense. And beyond that, if you look at any of the easy LeetCode problems and just look at the solutions that other people provided, it might be helpful that way too. Yeah. Yeah. Okay. Well, let's go consider some just like really basic dynamic programming problems. In fact, even ones that we've already done. because I think having these notes is probably more important than whatever else I'm going to do. So which ones have I completed? Squares of a sorted array. Man, I can't get this out of my head. Why is this in DP? Why is this here either? I'll look at some examples. In fact, let's just turn off the problem command for now. Introduction with examples. Yeah, this is okay. So this is kind of like what I was doing with OAuth notes yesterday. Like OAuth was another one of those things where I thought, okay, for system design, probably not super important, but if someone ever asks me, hey, can you talk about this? I thought I should be able to. And I had done all this stuff before. Typing out these notes again yesterday probably took like an hour, maybe half an hour. I don't know. It took a long time. And now I've got one place where I can always look back at it and just be like, yes, that's how it works. So that's what I want to do for dynamic programming as well. I have all these notes and clearly they didn't help. So let's get notes that do help so that in the future, this will just be fine. So introduces dynamic programming, provides two examples of demo code, text justification, and finding the shortest path in a weighted directed acyclic graph. 2 points below won't be covered in this article. Solutions that are better suited than dynamic programming, and situations that dynamic programming cannot be applied. All right, so it's a methodology that often yields polynomial time algorithms, solves problems by combining the results of solved overlapping subproblems. To understand the last two words, let's start with maybe the most popular example, calculate Fibonacci numbers. What is going on with this image? What? It's the weirdest thing I've ever seen. There it goes. Okay. knew I wasn't going totally crazy there. Solving f of I for positive number I smaller than 6. Yeah, man. I think I even have a diagram about this. Do somewhere here. I don't order overlapping subproblems. Yeah. Yeah, this all makes sense. This doesn't fit into my mental models all over the place. Top down, start with the original problem, recursively solving smaller, bottom up. Yeah, this stuff still makes sense too. The approaches doesn't take maximum integer precision into consideration. This doesn't really help me, I guess. I need to think of this step. This is the step that I think is broken for me right now. But I'm stuck on something here, and I don't know what it is. Yeah. Check out William VSET DP playlist. Yeah, I probably will. I'll write that down. The thing is, if I'm not combining it with the real world problems, and I think it's going to kind of be like what I had done with the MIT playlist, where everything made sense, and then I like solidified it, everything made sense, and then I forgot it all. Yeah. Yeah. So maybe it, man, I want to come back to this at some point, but I'm sure if I go to discuss, we're going to see dynamic programming solution, like at least a few times in here, probably that someone would have written it. Okay, no one actually wrote one. I am actually pretty surprised about that because again, I'm not so concerned with can we solve this a better way. I want to figure out how we have approached this from the dynamic programming perspective. I'm actually pretty surprised no one did it yet. No, I guess some people did. So yeah, maybe it's best to just look at this and see what happened here. Start from the left side, increase answer by 1 when you see a different number. Yeah, I think this further solidifies that I'm overthinking this. But I think this also indicates that even if this were a dynamic programming problem, I wouldn't have gotten it. I wonder too if, okay, I should probably, let's try some more. Yeah. I don't think I think instead of trying just random medium problems, we should just focus on this. Maybe that's what I should have looked at too. Where do we leave off with this? I wrote this at some point. Okay, I'll add this to my list up here. Okay, so go through these. And something else I wanted to say. Or was it? We had a whole list of these. Yeah, I wonder if I remember these other ones too. Okay, let's just do some DP problems then. Yeah. Let me put this back up here and let's keep going. So what I like to do for these is apply like just straight up the dynamic programming model to all of these, whether they'll fit or not. This is what I was doing too for something else. What was it? I don't remember. I don't remember any of it. All right. So given an integer array nums, find the contiguous subarray containing at least one number which has the largest sum and return its sum. So like I said, we're going to try to fit this exactly to this set of steps. And I think I'm going to hopefully identify what's going wrong here. So find contiguous subarray which has the largest sum and return its sum. So what they consider sort of these kind of concerns, prefix problems, suffix problems, and substring problems to be the issue that we have here. And here we have sort of a substring. So this is, we're going to need a starting index and an ending index, and either one of those things can change. So what we're going to try to figure out is, do we accept the current start index and change the end index, vice versa, and we consider everything in there. So define our sub problems. I wonder what this is supposed to mean for this step. And I wonder if I'll actually be able to do this without looking at these videos again, which I don't want to do on stream. The sub problem in this case is just going to be a subset of the array. Is that what I guess some part of the solution? I think this framework isn't serving me well right now. But I also don't think it really matters too much if I muddy these definitions. What problems you want to add? Yeah, maybe I should basically just identify prefix, suffix, substring, and then figure out how I would. No, they're two separate steps. First two steps are the hard parts. After that, everything's automatic. For every word, does it start a line or no? But those are the guesses. Okay, so I'm going to just turn this into something that'll make sense to me. So this typically involves these things. And then guess some part of the solution. So do we take this index? If so, does it increase our cost by some number? Is this a base case? In which case maybe we know the output for that base case. Yeah, maybe this is a better way of thinking about things. I think this is probably better. I think this at least makes more sense to me. And then this part I think is also really, really challenging. Okay, so then let's start. We said the subproblems of this, we're going to say that it's a substring thing, and then guess some part of the solution. But I think these go hand in hand, and that's where I was getting stuck on. So we say, do we take the start index? Do we take the end index? So in this case, what we're trying to do is find the maximum subarray. So maximum subarray, so we look at our recurrence that we're going to have. We want to maximize for DP, I, and J. So we want to maximize it so that we're taking either it's DP. Okay, now I think I understand how this is supposed to work. Is I plus 1J or DP of I, J minus 1. And then this would be the actual thing we're going to do, the sum of the array from I to J. Yeah. Okay, this makes a lot of sense now. Yeah. So I think I'm slowly resurrecting this knowledge, but I'm missing something here. Oh yeah, for loop. Yeah, for I from 0 to n, j from n to 0, stop when they cross, or stop when they meet, stop after they meet. Yeah, stop when they cross. Okay, let's write this down. So here's like sample summary of how to approach a real problem. So maximum subarray. And hopefully this is correct. I guess I should write this out. DP is dynamic programming. Command, do I have a command for that? No, I don't. Yeah, hey Metalstorm. Yes, I think this is fine, and I think then we'd have to write this code, and we'd have to figure out, do we want the top-down approach or the bottom-up approach? So we could start, our bottom-up approach, I guess, would have, like, start with each sum being, I never really talked about how you could reuse these things, though, did I? Talk about time complexity. Yeah. Yeah. I think I'm getting really, really stuck. So Why is there so much going through my head? Like I'm going to intentionally try to code this as an over end of the third algorithm. I'm ignoring everything other than how would you approach this with DP here. But actually, we could reuse information from previous cycles that we've done. And I'm just not thinking. Yeah. So here's, I guess, where we see this. If we start working kind of from the inside out, then we can base it off of the sum we already had. And I don't think I would do this with dynamic programming normally. I think I would, well, I don't know. Yeah. Reuse subproblems. So the sum of I to j is the same as the sum from I to j plus 1. I wrote this wrong. With the array j plus 1 added in. So we can memorize sums of ranges and use the one from the next range that we would have had. Yeah. What is not falling into place in my head? I think we should start with an even easier thing. Yeah, hey Gan. If you ever get the chance and want something random, appreciate being able to do a chat command, but the answer being whispered. I think there's a setting for that could be automatic, but I think I'd have to like recode the bot if I made it an option for everything. The other thing is that I'm probably not going to spend a lot of time doing that, given that I won't be streaming too much after a couple weeks. Man, I am stuck. I'm going to take a quick break. Yeah. What a shame. Just clear my head. All right, I'll be back in a bit. Yeah, see you guys in a bit. Whoops. I closed the wrong tab. I meant to. No, stop it. Yeah, I closed chat. Hang on a sec. I didn't mean to do that. All right. I think what I realize is that it's just not a good time to stream. And actually, what I also realized is this happened the last mock interview too. There was a mock interview the day before. Thought it was great. Learned a lot. And then the next day was terrible. And I don't know what causes that. And maybe it's just a coincidence. I slept incredibly poorly last night, actually. But I don't remember if I slept poorly the day after the last mock interview, too. So here's what I think we'll do. I think so. CEO of Coronavirus has offered to do a mock interview today, and that is 6 hours from now. So I think I'll come back for that. That'll be about an hour. Yeah, about an hour. So if you guys want to watch that, I'll do a stream for that. And if that goes poorly, I'll have to take some time before scheduling the real interviews, because I think this could mean we've got more practice than I might have thought. Alternatively, it could just mean I'm tired. I don't know. I think taking a nap is actually a good idea. I know someone suggested a coffee earlier. This is one of the stupid issues with not having coffee, is that I have no way to get more awake other than just taking a nap. So yeah, I guess that's what I'll have to do. But so sorry, this stream was pretty sucky. I mean, I don't feel like it was good, and I didn't really do anything. So I'll try to watch some videos or something and just kind of take some time off. So thanks for watching, guys. I'll see you in about 6 hours.